All right, so last time we took a look at this possibility that when we're dealing with law of sines, we can end up with a situation where we have more than one triangle possible. And we can end up with a situation where we have no triangles possible as well. So there's problems in your work, in your book and in your notes and in whatever, when you're working on My Math Lab and whatnot. They'll ask you this kind of a question. They'll say, determine the number of triangles. Okay? And one way to do that is to sort of go back to this sort of chart that I've put in here and try and match up the details and see which case you're in. But if you notice, the directions always keep going and they say this afterwards. Solve any triangles that result. Well, that means that when we have one of those cases that's not the first one, I'm going to have to do some solving anyway. So my suggestion to you is not to try and piece it together and try and figure out based on the restrictions and whatever which triangle case we're in and whatnot, but to just attempt to solve the problem. Because if it doesn't solve, it's going to become very clear very quickly. And if it does solve, it's going to either have one or two triangles, and I'll show you how you make that determination as well. Sound good? All right. So we're going to draw these, when we draw these, I should say, we're always going to draw them as though they're incomplete to start with, because that is the most general way of thinking about it. So I'm going to draw a triangle that looks like this. It's incomplete. So I realize that means I could complete it by continuing to draw it down. It means I also could complete it by swinging it back to the left-hand side, right, and drawing it down that direction. So this is sort of a very loose picture of what could be happening. Everybody with me? And I'm going to put my A, B, and C and whatever based on this information, that whatever angle I'm given is going to go down with the only angle location that I've drawn yet. So this angle A is where, this location, this angle is where I'm going to put my angle A, because it's the only angle that I actually have both sides information and whatnot for. Now, whenever I'm given the information that has the possibility of more than one triangle or none at all, I'm always given the information where I have the angle and the opposite side. Notice, right, I have capital A and I have little a, both pieces given to me. Capital A is 58, which means that the little a then is the opposite piece that's not drawn in all the way. So this is the 50. And then the third side, or the third piece of information, which is a side, is going to be the side that's between that angle that you're given and that side that you're given. So that's the 61 over here. Okay, so you're always going to be filling in sort of the left-hand, corner of this diagram. Okay. Now, if you want to imagine that there is, in fact, a line coming down here, then this point right here would be called what angle? What letter, capital letter, would that be? B. It would be B, because I've got side B. So we're going to imagine that there is, in fact, a point down there and pretend that we can actually set this up and see if it works. Okay? So law of sines says that I take the side that I'm given that I know, so that's my 50, and I write that over the sine of the opposite angle, which is 58 degrees. Thing's going to, I don't know, explode or something at some point. I'm not sure. Do you know what the popping is by any chance? Anyone? Okay. This is the only room that it pops in for me, so I'm not sure if it's something with the projector or what. And then I have another side, 61 here, and that will be over sine of B, which I don't know. 3 pieces of information. The piece I don't know is my angle. Everybody good? All right, so you can cross multiply, and if you do, you've got 50 sine B equals 61 sine 58. Make sure you've got your degree markers where they're appropriate, and they're always appropriate with these angles. They're always in degrees. Now what? Divide by 50. So I've got sine of B equals 61 sine 58 degrees over 50. And then I would do the inverse sine. Before I do inverse sine, let's get an approximation for what's going on the right-hand side of this at the moment. So grab your calculator, type in 61 sine 58, hit enter or close the parenthesis or whatnot, and then divide by 50. Well, at least 2 people to tell me what you got, so we make sure we got the same thing. Okay, I hear like 4 people. That's good. 1.03. And actually, give me 2 more decimals just for the sake of what we're going to be doing later. 4.6. You want to make sure you keep several decimals because when you round too early, sometimes it affects your rounding later on and whatnot. On this one, it doesn't end up mattering because what do you notice? Yeah, that's greater than 1, right? So there is no triangle here. The no triangle case is the easiest one to see and the quickest problem to do because I don't have to find any pieces of information because there is no triangle that's existing. So it really did look like that incomplete looking triangle that I drew to begin with. All good? Who wants to have one of those in the test? Yeah, so I thought. Okay. All right, let's take a look at another one. I don't think the test will only include that, no. But what you should notice is that I'm doing 3 examples. Right? And we already did the example where I had no triangles, so I probably have one of my last examples that has 1 and one that has 2, right? Yeah, this is how I do things, yes. Okay. So we're going to draw, we start the same way. It doesn't matter how the problem is given to us, we start it the same way. We have this sort of incomplete looking triangle. I have angle A down here at the bottom. It's 42.5. And the side that's opposite it is 15.6 feet. Side B, it happens to be a B again, is between them. It's 8.14 feet. And then the missing piece that I might or might not have down here would be called angle B. And we start there. The setup is identical to what we did before, right? 100% identical. All right. So when we're doing this problem then, we set this up as 15.6 over sine of 42.5 degrees. And it equals 8.14 over sine of B. And then what did I do next? Cross multiply. So I have 15.6 sine B equals 8.14 sine of 42.5 degrees. And then I divide. So this is sine of B equals 8.14 sine of 42.5 degrees over 15.6.
So you don't care if we don't write feet after everything?
No, not when you're working. No, you don't need to write it. I mean, if you did, it wouldn't hurt anything, but you don't need to. No, not at all. All right, so let's get an approximation with 4 decimal places for what we have going on the right-hand side of this equation.
0.3525.
Okay, so this is going to have a value, right? Yeah. All right, so some of you were already telling me last time what I needed to do next if it did have a value, and that was the inverse sine. So take your calculator and find the inverse sine. So inverse sine of 0.3525.
20.6
Here's where you have to decide. You have to decide that every time I'm doing this, I'm going to try this. Okay? We know we have at least 1 triangle. What we don't know is if we have 2. Correct? All right. If we do have a second triangle, I'm going to call it B2. Then there would be a second angle. Okay? So remember, what it would look like is it would look like this little piece right here swung over here. That's what it would look like visually if I had a second triangle. And the way that those are related, without me going into too much detail, but let me draw you a picture so you can see it. If you take this triangle and this triangle, and if they were drawn well and all that, then this angle and this angle right here, these have a relationship. And the relationship, although maybe not apparently evident right now, is that they're supplementary. They add to 180. All right? Okay, and that's a result of the fact that triangles add to 180 and whatnot, and if you do a little bit of algebra with them, it comes through. But they do add up to 180, which means if I have a second angle, the way that I find it is I take 180 minus the angle I already found. So watch this with me. So if you do 180 minus 20.6, what do you get? $159.4. So we can always find that. That's not a problem. But the question is whether or not that actually will work. So how you decide if it actually will work? Well, you take this angle that you just found as a possibility, and you take the angle that you know is already in your triangle, and you add them together in your mind or otherwise. And if you add these together, you will find out that these two angles added together exceed 180 degrees, don't they? I can't have two triangle angles that add up to more than 180. Agreed? That won't work. I can't have two triangle angles that add up to more than 180 because all three triangle angles have to add up to 180. So this will not exist on this one because it's too large. 159 and 42 is more than 180. So that's how you make the determination. You sort of plow through and say, well, if it existed, it would have to be this, 159. And then you say, okay, but then I look at that 149 or 59, and I look at the already angle I have, and I say, can that really happen? And in this case, I have to say, no, it can't. And again, that's actually the second best situation because that means you only have one triangle you're finding information about, right? And in fact, we found two angles, or we found one angle. We were given one angle, so finding the third angle is actually, and I'm out of space. How did I do that? I don't know. All right, so let me do this. I think I can do this. I'm going to regret something else later, but we'll regret it when we get there. Whoops. All right, so right now, right now I still need to find the third angle, which was angle C. How do I find angle C? So I subtract the two angles I had. One of them was given to me 42.5. One of them I found, what was it? 20.6. And if I subtract both of those each individually or added together from 180, what do I get? 116.9 degrees. Okay. But I'm not quite done. I need to find side C, right? That's the one side I don't yet know. All right, so the sides that I do know was side A. Side A was 15.6 over sine of angle A, which was 42.5. Side C is what I don't know, and angle C I just found, and I'll use it, sine 116.9 degrees. You can cross multiply here. We ran into this situation last time, but you can also simply multiply this piece to the other side because then that isolates the C by itself. So C is 15.6 sine of 116.9 degrees over sine of 42.5 degrees. What will side C be? 20? 6.8?
No.
Okay, 2 decimals on the measurement, so 6.8? Is it 6.59? Okay. 0.59 and then feet. All good? So you know what's going to happen on my last example, right? We will have 2 triangles. So let's start here. I don't have the slide that has all the information on it, so let me jot in for the information that we were given. I have angle C is 29 degrees. Do you remember this notation, 50 with a little hyphen looking thing? 6.1 meters. And C is 5.21 meters. The 50 with the little mark right there, what is that? It's minutes. How do I turn minutes into degrees? You have to divide by 60. What do I divide by 60, Eric? just the 50, right? So the 29 stays put, and then I have to divide 50 by 60 because there are 60 minutes in a degree, like 60 minutes in an hour. And so this angle measure is actually 29 what? With one decimal? 0.8 degrees. Okay, so that's actually my angle measure. All right, other than that, the problem starts out the same. Right? I set up this sort of impartial or incomplete looking triangle. I've got angle C down here, which is 29. This is problem number 5, by the way. 29.8 degrees. The opposite side is side C, so my 5.21 meters goes over opposite this. And then the side between them is 8.61 meters. All good? Everybody's going to set their triangles up like this, aren't you? It really will help because it won't sort of give you the image that there's only one triangle when there isn't always only one. All right, so we're going to set up my equation. So it's going to look like 5.21 over sine of 29.8 degrees equals 8.61 over sine of what? A, because this was side A. All right, so we cross multiply. 5.21 sine A equals 8.61 sine 29.8 degrees. And divide by 5.21, right? All right. So let's get a decimal approximation for the right-hand side with 4 decimals. That should keep our accuracy enough we don't lose anything after I do my inverse in a moment. What do you get?
.8213.
8213? Okay. Anyone else doing this along with us so that it's not just me and Lauren? Okay, good. Got the same number. Good. All right, so the angle A then is the inverse sine of this, right? Point, what was it?
2.
Okay. So this is one possibility, and the other possibility, A sub 2, would be to take 180 minus 55.2 degrees. So what is 180 minus 55.2?
124.8.
Okay. So 124.8 plus 29.8 is what? So I'm wanting you to add 124.8 and the original angle C, 29.8. What was it? 154.6. Is it under 180? Yes, so we have 2 triangles. Because when I added the original angle with the possibility of angle A2, right, that possible angle, I'm under 180, which means I do have 2 triangles here. So I know it looks like a lot, but I actually only have to find 2 more pieces of information because I really can find the angle B's pretty easily. So let's call this A1, right, so that I can call this B1. So B1 will be found by taking the 180 minus the angle I'm given, 29.8, minus angle A1, which is 55.2. This is angle B1. So what is angle B1 going to be? Even? Yeah, it would be even. Okay, so angle B1 is 95 degrees. And then we have angle B2. So angle B2 is found the same way. It's that same 180 minus the same 29.8. But this time it's minus angle A2, which was 124.8. Sorry, I can't get my decimal in there because I'm running into my guard at the bottom of my screen. What will this give me for B2? Now what do I have to find?
C2.
I don't have a C2. I only have angle C because it was given to me. So I don't have a C2. In essence, C1 and C2 would be the same thing. Like this picture over here. I've got a little sliver triangle that's got angle C in it here, and I've got this big outer triangle, and it's got the same C in it as well.
So if they give it to you, it's going to be the same?
Yes, because it is the same angle in the triangle. It's just creating whether it's a skinny little obtuse triangle over here or if it's a big outer triangle over here. I need to find, say it louder for me. I need to find little b, right side little b. I haven't found that yet. And I have two possibilities for it, correct? Yeah. Okay, so let's find B1. So finding B1 means taking the information I'm given for C, which is 15 point, no, that's the wrong problem, 5.21 over sine of 29.83, or 29.8, sorry, we left it at 8, equals, and then I've got side B1 that I'm going to find, and I need to use angle B1 to find it. What was my angle B1?
95 degrees.
95 degrees. So I've got sine of 95 degrees in this denominator. I can multiply this to the other side. So B1 is 5.21 times sine of 95 degrees over sine of 29.8 degrees. What's B1? With 2 decimals. Say it louder for me, Michael. 10.44. Do I have a nod from someone else?
Yes.
Yes, excellent. Units?
Meters.
Meters, because there are units in all these problems. I can set up the other problem almost exactly the same, right? It's the 5.21, it's the sine 29.8. All that's the same because side C and side C and angle C were both given to me. But finding B2 means using angle B2, which means I divide by sine of 25.4 degrees. Again, I multiply to the other side. So B2 is 5.21 sine 25.4 degrees over sine of 29.8 degrees. And then B2 is our very last thing for today. 4.50, and it's meters, right? Okay, and that's how you would finish it out once you found that there's 2 triangles.